this video we're going to be covering advanced BGP. Specifically, we're going to cover the necessity of BGP, then we'll dig into BGP functionality, path vector attributes, the scalability of BGP using route reflectors and confederations as well. So let's begin. BGP is used to route between autonomous systems and is considered to be a path vector routing protocol. Routing decisions are based on multiple attributes that can be tuned and controlled, resulting in the particular path the AS's data will take. This is more of a policy-based routing approach, and policy routing is very important for internet service providers routing traffic between each other for different ASs. BGP is a classless routing protocol, and it supports VLSM and summarization. While IGPs can scale to thousands of routes, BGP can scale to hundreds of thousands of routes, making it the most scalable routing protocol ever developed. Another characteristic of BGP is its high rate of stability. As there is never a solid convergence of the internet routing table, that is, something is always changing in such a large routing table, this is obviously very important to be stable. In addition, it is stable enough to handle routing and decision making at the same time. Because BGP focuses on the enforcement of policies, it does not use a simple metric value that might be tied to a single parameter. Instead, BGP has a group of attributes that can be manipulated to dictate a particular routing policy, and you will learn about all of those attributes in this video. When used to exchange routing information between organizations, BGP can be configured in two particular ways. As a transit network, that is, when ISPs want to provide transit to other destinations on the public internet, or a multi-homed network. Big enterprise networks that rely heavily on internet traffic and have sophisticated connectivity requirements would use this methodology. If the connectivity connects to two or more ISPs, BGP allows them to control inbound and outbound routing policies. Most of the enterprise networks do not need BGP. This can be for various reasons. First, the network requires single ISP connectivity and default routing is sufficient. A default route will simply point to the ISP, so all internet traffic is routed out that single connection. Memory and CPU resources are limited and do not support BGP implementation. Since the global routing table needs more than 1 gig of memory just for storage, obviously not every business will have that much memory or capability. Finally, not owning the IPv4 address space in use. This happens in situations where the organization's addresses are owned by the ISP, which is a frequent occurrence for small and medium-sized organizations.
Now, regarding BGP path attributes, there are some that you absolutely have to know and memorize. The first is weight. Weight influences a best route for the local router, and obviously it's manually configured. Local preference influences the best route for all routers in an autonomous system, so this is a shared attribute. AS path lists the number of autonomous system numbers in the path, and this can be manipulated. Origin is a value implying if the route is from an IGP or an EGP. And then finally, the MED, which can influence the best route for routers in another AS. So you can influence traffic flows into your AS by sending out the MED to other routers. So here you can see we have two routers that are in autonomous system 700. And then upstream, we have another router in autonomous system 140 and autonomous system 87. So here you see there are 4 hops. But as far as BGP is concerned, it's just counting ASs. So it counts 1, 2, 3 ASs. The AS path is 700, 140, and 87. Why is this important to know? Because here's another flow that has 2 routers in AS 700 and then 1 router in AS 87. Now, according to this path, there's just 2 ASs. That would be the preferred path. It's critical to understand that BGP is concerned about AS path and not so much about hop count. AS path is a key attribute to understand. Now, internal versus external BGP. iBGP is something you would run basically interior to your company. It's BGP connectivity within the same autonomous system. In this, routers do not update AS path. Normally they should never have to because you're running the same autonomous system. And in iBGP, things should always be meshed. Routers should always be fully meshed. And there are ways you can get around this, and we'll talk about that in a little bit. Now, eBGP is external connectivity to other ASs. And routers do update the AS path in those cases. So let's say we have an autonomous system, 200, and in our company we're running iBGP full mesh between all routers. And let's say we have connectivity to two upstream providers. One is Autonomous System 301 and the other provider is Autonomous System 450. Now, between ourselves and our providers, we are running eBGP because it's two different ASs. And internally, we are running iBGP because we are communicating between the same AS. Now, configuration between iBGP and eBGP is quite similar. The main difference is you're choosing to communicate with the same AS or a different AS. Now, let's say we want to communicate to a web server over the internet, and we have a certain amount of hops. Now, let's say one of those paths through AS450 takes us through quite a few more hops, but it takes us through fewer ASs. So let's just say, for example, we go through AS900 and then AS100. So that's 450, 900, and 100. Those are the three ASs we traverse in order to reach that route. Now let's say on this flow through Autonomous System 301, we go through fewer hops but more ASs. Now, even though there's fewer hops, because there are more ASs, we're not going to prefer this route. There are 5 ASs in this path. That is not going to be preferred to the other path, which has only 3 ASs. So we're going to choose that path. We'll choose the 3 AS path. Now, let's say we're running a web server inside of our company, and we're running iBGP between these 3 routers, and we're connecting to 2 upstream providers using eBGP. And let's say we have users on the internet who are trying to get to this web server. We can manipulate the AS path attribute in BGP to make them prefer one path over the other. And the way we do that, and let's say our autonomous system is 50, we can manipulate the AS path attribute by adding to the AS path on one of our links. So, for example, the users know that they can reach the web server via one AS. Well, we're going to increase that on the top router, and we're going to manipulate it manually and add our AS over and over again to the AS path attribute. And the users, as far as BGP is concerned, that now is a longer path, and therefore the users will prefer the bottom path because it's only one hop, one AS hop. Now, if that router were to fail, users would then prefer the other path. So you see, you can manipulate traffic flows that way. Now, you need to understand the concept of public and private ASNs, and this shouldn't be foreign to you because you understand public and private IP addressing. So autonomous system numbers are chosen from this pool, and you can use them for private use or public use as need be, but you should be aware of that chart. Now, regarding BGP updates that we receive from neighbors, you can receive from your provider a default route only, which many people do, Or you can receive a full BGP routing table. That is literally every route that's available on the internet. Or you can receive just partial updates, and that is maybe the provider knows about certain routes via a better path than most other providers. You can just receive a partial update from your provider. So you should know that you can receive those 3 different types of updates. That should be known for your CCNP route exam. Now, regarding advertising routes, advertising BGP routes can be done 4 ways, either through the manual network command, redistribution of BGP into IGP, or propagation of existing BGP routes, or again manually using the aggregate address command. Maybe the best way to explain these is to simply draw it out. Now imagine we have a router with an iBGP connection and an eBGP connection to an upstream provider. So there's our eBGP connection, here's our iBGP connection, and we're autonomous system, let's say 400. So on a router, we can advertise in 4 different ways. We can manually specify the network we want to advertise by literally typing it in, network 10.10.10.0 or network 198.110, and we can forward that via iBGP and or eBGP. The other way is we can learn routes via BGP and redistribute that route into, let's say, an interior routing protocol. Let's say if we're running OSPF, we can take the routes we learn from our eBGP neighbor and redistribute them. The other way is to simply pass the routes we're learning from our eBGP neighbor via BGP internally to our iBGP neighbor. So that's just forwarding the information on. And finally, we can again manually set an aggregate address on the router, and that's a manual configuration to aggregate some of the routes. And again, that can be advertised out either way. So the rule of synchronization in BGP, you should simply know this, that BGP will not advertise a route unless it knows about that route via an IGP. That's what you really need to know for the exam. Now you can disable this by typing no synchronization on your router, and then it will simply forward routes that are not in the IGP.
So here's what you've learned. You've learned about the advanced BGP information you need for your CCDP architecture exam, including its necessity, its functionality, path vector attributes, and its scalability through route reflectors and or confederations. Good luck in your studies.